Right, this is the C3 EDEXCEL June 2013 paper, and we're on question 5. We're told that x equals sec squared 3y, and so therefore dx by dy, well, it's sec 3y to the power 2, so it's 2 times sec 3y to the power 1. Then we need to differentiate sec. Sec differentiates to sec tan, and then we need to differentiate 3y, and that's 3. So that altogether is 6 sec squared 3y tan 3y. That's part A done. And now we need to, in part B, get dy by dx in terms of x. Well, we know that 1 plus tan squared equals sec squared. So therefore we can say that tan squared 3y is sec squared 3y minus 1. So we get dx by dy is 6, then sec squared, or sec squared is x, and then it's tan 3y, or tan squared 3y is x minus 1, so tan 3y must be the square root of x minus 1. So therefore dy by dx is 1 over that, as required. So now we need to, in part C, work out d2y by dx squared. So it's going to be a quotient. Let's differentiate the top one first, that's 0. Differentiate the bottom one second. So that's now a product. If we differentiate 6x, it's 6. And then if we leave 6x alone and differentiate x minus 1 to the half, it's a half of 6x times this to the minus a half. And it's all over the bottom one squared, so that's 36x squared x minus 1. Lots of ways to go from here, but quite a neat way is to multiply the top and bottom by x minus 1 to the half. So we get minus 6 x minus 1 to the half times x minus 1 to the half, which is just x minus 1. Then we've got 3x, and we're multiplying, remember we're multiplying top and bottom by x minus 1 to the half. X minus 1 to the half times x minus 1 to the minus a half, that's just 1. And then if you multiply the top by x minus 1 to the half, you have to multiply the bottom by x minus 1 to the half. So we've got this. Let's tidy that up. Minus 6x minus 3x is minus 9x. Oops, there we go, minus 9x. And we've got minus 6 times minus 1, which is plus 6. All over 36x squared x minus 1 to the 3 halves. And then let's divide top and bottom by 3, so it's minus 3x plus 2 over 12x squared x minus 1 to the 3 halves. Now in question 6 part A we have to solve this equation. So let's write everything in with the inside the lunds. So we've got a 4 minus 2x, it's plus, so that's 4 minus 2x times 9 minus 3x. This 2 goes inside as a power, on the other side it becomes a minus, so when we do a minus it's divided by x plus 1 squared, and that's 0. So therefore 4 minus 2x times 9 minus 3x, well ln of 1 is 0, so all of this bit has to equal 1, so we then get x plus 1 squared on that side. We need to multiply it out, so that's 36 minus 18x minus 12x plus 6x squared equals x squared plus 2x plus 1. So we've got 5x squared, got minus 30x here, minus 2x, that's minus 32x, got 36 here, got a 1 there, so that becomes plus 35, and that equals 0. Then we need to factorise that expression, so it's 5x minus 7, x minus 5 equals 0. so therefore x is 7/5 or x equals 5. But x can't equal 5 because ln is only defined for positive numbers. But x equals 5 is not defined because, anyway, we were told x is between -1 and 2. Therefore x equals 7/5. In question 6, part B, we've got 2 to the x, e to the 3x plus 1 equals 10. So let's take ln of both sides. Ln of 2x e to the 3x plus 1 equals ln 10. Ln of two things times together is ln of 2x plus ln of e to the 3x plus 1. So therefore ln of 2 to the x plus, well, ln of e cancels out, they're inverse operations. This x comes down as a power, so x ln 2 plus 3x is ln 10 minus 1, putting the 1 on that side. X is now a factor, so therefore x equals -1 plus ln 10 over 3 plus ln 2, and that's in the format that they want. Here we have question 7, and in question 7 part A you're asked to write down the range of f, in other words the y numbers, from 0 up to 10. So we get 0 is less than or equal to f of x, which is less than or equal to 10. In part B, we're asked to find f of 0. So if we put 0 into this function, we get this value here. This is 2, 0. This is -2, 10. It's a straight line, so halfway along must be 0, 5. So f of 0 is 5. But we want f of 0. In other words, we now want f of 5. We've worked out f of 0 is 5, so that part there, f of 0, that's 5. So we need to work out what value we get when we plug in 5. Again, this is a straight line, so it's 2, 0 to 6, 4. It goes along 4, it goes up 4, so the gradient is 1. So every time we go along 1, we go up 1. So this point here is going to be at 5, 3. This point here would be 4, 2. That point there would be 3, 1. It's going along 1, up 1 every time. So anyway, f of 5 is 3. In part C, we need to work out an inverse function. So let's do it this way. Right, y equals 4 plus 3x over 5 minus x. So let's multiply both sides by 5 minus x. And now let's make x the subject. So we've got x into 3 plus y on that side, and 5y minus 4 on that side. So x is 5y minus 4 over 3 plus y. So therefore the inverse function is 5x minus 4 over 3 plus x. Now in part D, we'll need to solve the equation gf of x is 16. So there's some number in here that g of that number equals 16. So g of something equals 16. So what number, when we put it into g, gives 16 as the answer? We could solve that equal to 16. 4 plus 3x over 5 minus x equals 16. But we'd go through the same process that we did here, because this is the inverse function. So you can do it this way, put 4 plus 3x over 5 minus x equals 16 and solve it. Simpler to put 16 into here, because this is what the inverse function is, it's working backwards. Put 16 into here, 5 16s are 80, take away 4 is 76, 3 plus 16 is 19, 76 over 19 is 4. So basically we're saying that f of x has to equal 4, since g of 4 equals 16. And then how did I check that? I did g to the minus 1 of 16, and I got 76 over 19, which equals 4. So now we're down to the situation where we need to solve the equation fx equals 4. So f of some number is 4, and so if we look at the graph here, we're going to get two possible answers. My graph hasn't quite lined up properly, but basically it's going to be those numbers there. That point there, f of 6 we know is 4, so therefore we've got x equals 6, but also we've got this point here. So this is a straight line. 4 we know is 4/5 of the way up that line, so it must be 4/5 of the way back from 2. 4/5 of 2 is 8/5, so 2 minus 8/5 is 2/5. Now question 8, which is much easier than it looks. So we need to express 24 sine theta plus 7 cos theta in the form r cos theta minus alpha. Put those brackets in. So let's think of a magic number. 7 squared plus 24 squared is 625, take the square root is 25, so therefore we get 25 and then 24 25ths sine theta plus 7 25ths cos theta. Compare this expression with this expression. There's sine theta, so sine alpha is 24 25ths. So slightly confusing in that this bit appears backwards here, but the sine theta there, so sine alpha is 24 25ths. So we do inverse sine of 24 25ths, and we get 73.74 degrees. And let's make it absolutely clear that r equals 25. In part B, we need to find the minimum value of v. So v is 21 over this expression that we've just worked out, so it's 25 cos theta minus 73.74. So we want the minimum value of v. So the minimum value occurs when this is as big as possible. The bottom bit has to be as big as possible. So the maximum value of cosine is 1. So the minimum v is 21 over 25 times 1, which is 21 25ths. Now in part C, it says that Kate's speed has the value found in part B. So in other words, we know that v is 21 25ths. When is v 21 25ths? So the minimum occurs when cosine theta minus 73.74 equals 1. In other words, theta minus 73.74 is 0 or 360 or 720 and so on. So let's add 73.74 to both sides. We get 73.74 degrees. Clearly the angle is not 433.74. And in part D, we're told that v equals 1.68, so 1.68 equals 21 over 25 cos theta minus 73.74. So a little bit of algebraic manipulation, and we get the cosine of theta minus 73.74 is 21 divided by 25 divided by 1.68, which works out to be 0.5. So therefore theta minus 73.74 is 60, 120, numbers bigger than 360, but also minus 60 and minus 120 and so on. So let's add 73.74 to both sides, and we get 133.74 from here. This bit we get a number over 150. We're told theta is between 0 and 150. Minus 60 plus 73.74 gives us the other angle, 13.74, and minus 120 gives us a number that's too small. So question 8, that looks terrible, looks like a mechanics question, is reasonably straightforward.